Azure OpenAI service provides several generative AI models optimized for various tasks like natural language processing, translation, and summarization. Models include GPT-4, GPT 3.5, and Codex. Each model has specific characteristics that make it suitable for particular use cases. Choosing effectively involves understanding your scenario's needs regarding accuracy, latency, computational cost, and capabilities. Azure OpenAI models are deployed within Azure infrastructure, offering scalability, reliability, and compliance benefits inherent to cloud services. Defining clearly your requirements is vital before selecting an Azure OpenAI model. Consider questions like, what kind of task is needed? Text completion, chat interaction, code generation? What complexity level is required? Deep language understanding, or simpler conversational capabilities? Assess the expected response length and complexity, latency requirements, and throughput needs. Reflecting on previous content about use case determination will facilitate precise model choice aligned with your project's constraints and expectations. Model features best for GPT-4 high performance, multimodal advanced tasks, detailed responses GPT 3.5 turbo efficiency, rapid responses general conversational task Codex coding assistant. Code completion software development scenarios understanding features helps match models with tasks. Tasks demanding accuracy and in-depth analysis suit GPT-4. GPT 3.5 turbo is advantageous for quick responses in conversational bots, and Codex specifically benefits coding and software-oriented projects. Deploy Azure OpenAI models near your users to minimize latency and enhance responsiveness. Azure offers worldwide regions. Consider geography, legal requirements, and regional compliance standards when selecting. Also examine availability, redundancy capabilities, and disaster recovery features of the region. Azure regions like East US, West Europe, and others have broad support for OpenAI services, allowing seamless deployments globally. Strategic region selection will optimize service efficiency while maintaining regulatory compliance. Provisioning involves creating an Azure OpenAI service resource within Azure Portal or via Azure CLI. Configure settings like subscription selection, resource group assignment, region selection, and pricing tier. After provisioning, service keys and endpoint URLs become available, enabling API integration and access management. Ensure proper naming conventions and resource tagging for effective management and cost optimization. Prior understanding of Azure resources provisioning simplifies this process significantly, minimizing configuration errors. Deployment within Azure involves selecting the previously provisioned resource, then choosing a specific model variant to deploy GPT-4, GPT 3.5, or Codex. Assign unique deployment names to identify and manage deployed models easily. After deployment, API endpoints specific to the deployed model will be generated, enabling integration into applications and tools. Deployment configuration options include scaling configurations, allowing adjustments in capacity to optimize consumption and performance per your application's requirements. Azure facilitates comprehensive management of deployed AI models through Azure Portal and Azure CLI. Administrators can monitor model usage, performance metrics, and consumption patterns to manage cost and resource allocations. Version control capabilities facilitate seamless handling of updates or rollbacks to earlier model versions as needed. Azure OpenAI management functionalities further allow modification of resource scaling parameters and reconfiguration of deployment specifics, adjusting dynamically to project demands and changing conditions. Azure provides built-in monitoring tools like Azure Monitor, diagnostic logs, and dashboards to track OpenAI model performance. Metrics such as latency, throughput, error rates, and request counts are critical indicators of operational health. Use Azure Application Insights for more detailed analytics, highlighting performance trends and possible bottlenecks. Understanding previously covered evaluation methodologies facilitates proactive performance optimization, ensuring continued improvement and responsiveness from your deployment. After deployment, Azure OpenAI models integrate via REST APIs and Azure SDKs, .NET, Python, JavaScript. You can connect models directly into web apps, chatbots, or backend processing systems. Utilize Azure AI Foundry SDK to expedite integration and streamline development processes. Application integration often involves configuring authentication using API keys or Azure AD for secure model access. Documentation and existing SDK support streamline this integration process significantly, promoting rapid deployment of intelligent features in existing applications. Azure supports automatic and manual scaling for OpenAI model deployments, ensuring applications sustain peak performance even under heavy usage. Horizontal scaling allocates additional instances to handle increased workloads smoothly. Vertical scaling adjusts compute resource capabilities of individual deployments to match performance needs. Scaling approaches depend on factors like concurrent user loads, average response time needed, and cost management targets, all aligning with previous resource planning considerations. Azure OpenAI service is compliant with numerous regulatory frameworks, including GDPR, HIPAA, and SOC compliance. Ensure proper security configuration utilizing Azure's built-in features, like virtual networks, firewalls, and private link integrations, to mitigate unauthorized access. Data residency and privacy controls help meet geographical and industry-specific compliance demands. Regularly audit deployments for security compliance using Azure Security Center, aligning your AI deployment with organizational policies, reducing risks and liabilities. Cost management is integral when utilizing powerful Azure OpenAI models. Azure cost management tools help visualize expenditures, establishing budgets, and predicting future costs using spending analysis. Factors affecting costs include model type, region, instance sizes, number of requests processed, and scaling configurations. Careful planning and regular monitoring help maintain project sustainability economically. Adopting cost-effective strategies, including selecting appropriate models for specific tasks, optimizes overall investment versus operational value provided by generative AI solutions.